You can spend thousands of dollars organizing a factory floor, applying strict cleanliness standards, and ensuring every tool is in its place. Yet, despite that immaculate surface, production can remain paralyzed by mountains of unfinished parts sitting idle in the aisles. When a seemingly clean factory gridlocks, the problem rarely stems from physical clutter. The failure sits in the facility's underlying control logic, the rules dictating how and when work moves through the line. In the push system, centralized forecasting software attempts to guess future customer demand. Based on that guess, the master node simultaneously issues identical heavy work orders to every single department, requiring them all to start building at once. Because departments operate at different speeds, this simultaneous push creates inevitable bottlenecks. If the welding station is faster than the cutting station, inventory piles up in front of the slower machine. The central software acts like a traffic cop, forcing more cars into an already jammed intersection. These complex prediction algorithms often result in perfectly scheduled gridlock rather than manufacturing efficiency. Siam e-bike provides a clear look at how this logic impacts a business. Every morning, their centralized push software ordered the simultaneous production of 100 bicycles across all departments. The welding department completed 100 finished frames in record time, but the assembly department ran out of handbrakes at bike 40. 60 unsellable bicycle frames clogged the factory floor, trapping the company's cash in useless inventory. Meanwhile, the warehouse held 2,000 extra bike seats ordered months in advance by the same faulty prediction software. Solving this multi-million-dollar software failure requires a shift away from high-level forecasting toward a solution as simple as an empty plastic box. Taiichi Ohno was the engineer who recognized that the core flaw of global manufacturing was its reliance on guessing. Ohno found his inspiration while observing the physical restocking logic of an American supermarket. In a supermarket, workers only replace the items a customer physically removes. If 2 cartons are bought, 2 cartons are brought from the back to refill the shelf. Ohno applied this logic to the factory, creating the pull system. The final customer's purchase acts as the starting pistol, triggering a backward domino effect. Each station pulls only what it needs from the station before it, all the way back to raw materials. Reversing the flow allows a factory to react to the reality of a sale rather than predicting an imaginary future. This reverse domino effect is managed by a decentralized analog signal called Kanban, or signboard. For major components, workers use a card Kanban. Under this system, a machine operator is prohibited from starting work until a physical card arrives at their station requesting a specific part. By ensuring operators wait for a card before starting their machines, the factory mathematically eliminates overproduction. For smaller, continuous hardware like screws or bolts, factories use a 2-bin system. As the volume in the first bin drops to 0, the empty box itself becomes the physical command to restock. The operator shifts to the second bin, which provides the buffer needed to keep production moving while the first is refilled. Adopting these physical signals allowed Siam e-bike to reduce warehouse space by 50%. Warren Buffett famously noted that you only find out who is swimming naked when the tide goes out. In traditional manufacturing, excess inventory acts as high water, submerging the jagged rocks of a broken business, slow machines, poorly trained workers, and defects. Kanban drains that water. Limiting signal cards drops the water level until the production line crashes into these now exposed vulnerabilities. A jam in the Kanban system functions as a forced alarm. It compels management to address the root cause of a delay rather than covering the problem with surplus parts. Kanban serves as a relentless diagnostic engine, removing the safety net and forcing an organization to face the truth of its own inefficiencies.